So the type of problem we will be showing you is a freefall problem. With freefall problems, you first always want to identify which direction that the problem is going in, either the X direction or the Y direction. The problem that we are doing is going to be in the Y direction, so you'll draw your little picture and your arrow to show you which direction you're going in. There will be two equations that we will use for this problem. The first equation will be y equals y naught t plus v y t plus 1/2 g t squared. That's the first equation. The second equation will be vy equals v naught y minus gt. Now we're going to start by identifying the variables. First, we need to identify the y, which is 0 meters. The y will be down here. Then we'll need to identify the y naught, but that is what we're looking for because we don't know. And y naught equals our initial height, and then y is our final height. Vy will equal negative 13.82 meters per second. And then our time will equal 1.41 seconds, and our v naught y will equal 0 meters per second. That will be our initial velocity that we're going to know. Vy is our final velocity, t is our time, this is y naught what we're looking for, and this is our y, which will be our input right here.
Okay, so this is a free-falling project, and for this project we're going to be solving for, well, in the first part we'll be solving for velocity using the Vy equals V initial y minus gt, and our variables we have V initial will be 0 because we're dropping the ball from rest, and t, when we did the project, it was 1.41 seconds, and g is 9.8 meters per second because meter per second squared, because it's gravity. And that is our equation we'll be using to solve the equation, to solve for v. So we'll plug everything in. We're not going to write 0 because it has no value, so we'll just write negative 9.8 meters per second squared times 1.41 seconds, and we got 13.82 meters per second, and it's negative, and that is the answer we got for the final velocity.
So now we want to find, we know that the ball drops, and that's what, 0. We're going to have that as 0 meters. We want to find how high up this guy is, so pretty much this length. We're looking for a y initial. All right. So what we want to do is look at our kinematic equations and find an equation that is solving for y naught. And looking through our equations, we find the equation to be y equals y naught plus v naught y t plus 1/2 gt squared. Now we're wanting to get y naught by itself, so we need to pretty much move our variables around until we get y naught by itself. The easiest way to do that, honestly, is to just move this variable and this variable to the other side. So by doing that, we're gonna have y naught by itself. We're gonna end up with y minus v naught y t minus 1/2 gt squared. Now that we have our equation, we're going to plug in our variables. Better what I'm writing. The 0, we're not going to write that because we know 0 is 0. We're just going to write out the v naught, the vy t minus the 1/2 gt squared. So having that, it's minus, but then the answer itself was negative 13.82 meters per second times t, which was 1.41 seconds. Then we're gonna have that minus 0.5 times 9.8 times 1.41 squared. All right. So firstly, we want to get our units down. I know this is a little sloppy, but just follow along. 9.8, we know that that was meters per second squared. The time was in seconds, but we're squaring it, so it'll be seconds squared. So these seconds will cancel out, left with just meters, and then these seconds will also cancel out, so we'll just have meters left over as well. Multiplying these two, we'll get a negative number, but then having negative times a negative, we're gonna get a positive, and we'll end up getting 19.49 meters minus 0.5 times 9.8 times 1.41 squared. You end up with 9.74 meters. After that, you just subtract, and your final answer will be 9.75 meters. And that is how high the person had dropped the ball. 9.75. All right. If you wanted to check your answer to make sure that everything came out correctly, you could just as easily plug back into the original equation up here. We know that y was, we could plug in, and plugging back in, we could get y naught has 9.75 plus, we work that out to equal negative 19.49, and then plus 9.74. Work that out, you end up getting 0, which just proves that this is our correct measurement.